Hi, let's make it snow using Dyalog APL. So, in order to start our project, we will create in the root of the workspace, that's here where we work, a connection to a directory. And now we have to have a function, of course, and it's a good idea to have the main function be called run because this allows some neat functionality where you can run your APL programs directly from outside APL. So here's our run function. And we're going to start by setting up some parameter. We need to take an argument, of course. And then we have to specify what size landscape we want. And if we look over here in the configuration under the windows here, we can see that a normal edit window has 80 columns and 30 rows. So that means when we opened up this window here, for example, it has space for 80 columns and 30 rows. So let's just use that. So the number of rows is 30 and the number of columns is 80. So don't forget to localize our variables. Okay, so we're ready to go. We want to have some snow symbols. And what we're going to use is X, O, and delta. They kind of look a little bit like snowflakes. But I want to have more X's than O's and more O's than deltas. And I can do that in a little bit of a clever way by taking the prefixes. Now we can see overall we have 3 X's, 2 O's, and a single delta, and then we can just flatten that in list. So we can specify that like that. And the same way we can do with our stars, because I want to have a like a starscape behind the snow. And we're going to do the enlist of the prefixes. And then for stars, I'm going to use some special characters. It will become apparent afterwards why I'm choosing these 3. And then at the bottom of the sky, we want to have a landscape. It's going to have some trees. And for that, we'll use the APL symbol upgrade because it looks a little bit like a tree. And then somewhere on the sky, let's also have a moon. And depending on the phase of the moon, it can either be an open paren or a closed paren. Okay, so now we need to generate the actual sky and snow and so on. So let's say we have some characters here. Let's just take these for now, and we can take some random ones. So we can see this has length 3, so we can get a random one like this, and we can get a bunch of random ones. Let's also add a space after that, so we can aren't just filling the sky with snowflakes and stars and so on. Oh, I need to increase this by 1 then from the extra length. But we really should have more empty space than we should have content. So we can take this number here and multiply it by some factor that gives us kind of the density. So let's say that we do a 10 times multiplication factor. That of course gives us numbers that come way too large. So we need to have this length over here as a maximum. So the length is the maximum. So then we only get very few of them. You can see here, there. Occasionally we might get more, but it's mostly spaces. And let's define all of these variables in the session here so we can play around with them. variables don't get written out to our project, so we just use them as temporary variables. So we have we want a width, and that's a number of columns, and then we have a multiplication factor here, and then write it all out so we can view this, and we can see we get a nice line of spaced out snowflakes like this. Okay, let's take this formally here and roll that into a utility function. So let's call that put. We're putting things in. It takes a left argument, which is going to be those characters that we want to spread out, and then it takes a right argument, which is the multiplication factor. Then we have to take the length of the left argument here, and then we use this global of setting for the number of columns. So now we can do, we can take, for example, tree, put spaced out with 5. So it gives us a nice treescape, right? Random one. And that's just with a single one. Then we can do snow, and we get various snow. But of course, we probably want that spaced out a bit more. So what might be a good value? Maybe like a spacing out of 30. We get a little bit of snow in every line. And some lines will not have any snow. Okay, and then we want some stars. And for stars, we can maybe space them up even more. See, here's an empty one, another empty one. There's one with just one. But we actually want a whole star scape. So how many lines of stars do we actually want? Well, we want as many as we have rows, but one. Right, so we subtract one because the bottom row should be reserved for the trees, not for stars. So we take this and we use that to reshape 40, and then for each one of those, and we bind the left argument of the stars to the put function, so we get a monetic function, which is star putting, and each one of these 40, and then that's a nested array. We can mix that. We could also use the rank operator, and then that gives us a nice starscape. Right. So now we can start putting it all together. Let's call this the sky for now. And then we want to place a moon as well. So there's the moon, and we want the random one of the length of the moon. We could always add more types of moons if there was. And we want to add that at a certain location, and that's going to be similar to this, where we subtract one. So we want a random number for the row number that's up to one less than the number of rows, and then we want in any column whatsoever. So it gives us a random location for the moon. If we enclose that, we can use the add operator to place a random moon in the sky. And then let's view that. So here we have got a random moon down here, and here's another random moon up here, and there's one over here. This one goes the other way. Okay, so let's copy this into our function. So the sky itself, we generate like this. And so this is going to be our sky. The put function, we should make sure to get one as well. Put it up here and localize that. And the sky. Okay. We also need trees. So this is just the stars themselves, and then we concatenate below it. It's going to be the same kind of thing exactly. So we do a tree, put 5, we said. parenthesis is just to make it easier to read it, not technically necessary. Okay. Then we're going to generate some snowflakes that we're going to superimpose on top of this backdrop. So we call these flakes. Let's initialize that with rows and columns of just spaces. And then we have our main game loop, so to say. So okay, so what are our steps going to be? Well, we have to make the flakes, the snowflakes, fall down. So how can we do that? And if we drop the last line of the flakes, and then we add a new line of flakes on top. So we've got the snow symbols, and we put that spaced out with 30, let's say. And now we're going to actually draw the flakes onto the backdrop. So we're going to have a window, and that's what we're eventually going to show on the screen. And we don't want to draw all the characters in the flakes array because it contains all these spaces that are just going to blank out everything. So which ones is it that we want? We need to have a mask that decides which ones we're going to draw. So if there's a tree and there's a snowflake falling there, then we don't want to draw this snowflake. It can't cover up a tree. So sky is that backdrop. So if we want it to be where there's not a tree in the sky, and we also don't want to draw something where that's just empty space between the flakes, because that would blank out things between them. So the mask is this, where it's not a tree and the flakes are actually have content. Okay, so now add this mask on the sky. We draw, and here we need to do something with the mask, because we can't apply multi-dimensional mask. So let's say we have a mask which is 3-4 reshape 2 here. So here's a random mask, and then we have the alphabet 3-4 reshape quad A. Now if you try to apply this mask, it doesn't work. Arguably it should work, but as the language is right now, it doesn't. If we pre-process both arguments with the ravel function, then we can apply the mask and we get a flat result back. And that's exactly what we want for the add operator. It's supposed to take a just a list of the elements that are being put into these positions at those locations indicated by the mask. So mask replicate over ravel on the flakes. And now we've drawn these snowflakes on top of the backdrop. Of course, we need to actually show this this window to the user. Otherwise, I mean, we might be drawing the whole nice snowing scene, but you can't actually see what's going on. So before we even start, let's initialize the window, and then we open an editor in a background thread, because otherwise it will block and we'll just sit there and look at it at empty, and then when we quit it, we'll continue. So we want to open it in a background thread so that the editor window stays open while the program continues, and then we're using this feature of the Dyalog Editor that if you update the value of an array that's being edited, the editor will reflect the new value immediately. So this is the window that we're going to edit. And then we need a sleep here. So let's sleep an 1/8 of a second. It's a nice frequency. And let's see if we haven't made any mistakes. We can try running this now. So let's save this and run. and it's snowing. Of course, this gets a bit boring to look at. We can improve this. Also, there's no way to stop this, so we have to issue an interrupt, and then we can quit. Okay, let's. How can we fix this? If we run this whole program in a background thread instead, then it looks much the same, but now we can actually go in and interact with the session here, and we can ask what threads are running. 0 is the main thread, and then 32, that's got to be our animation thread. So if we kill the thread 32, that kill that. Okay, well, we can actually ensure that the program runs in the background thread. So let's do that. So since we can, if the thread ID is 0, that means we're running in the main thread. That's not right. Then we call ourselves in a new thread. We can give it arg, even though we're not actually using it for anything. And if now this spawns up another thread, and then we want to terminate this one. And for good order, we should probably return the result as well. But what could we return? We could probably return the thread that's being been launched, but let's do that silently because it's not really very useful. Result. Okay, so now if you run it like this, so now it runs in the background thread. 38. It would be nice if we could make the behavior here a little bit better. So let's over here, after we open up the window, we can enqueue an event to the session of getting the focus. So now, if we run this again, now we can see the cursor is down here, so it's ready for action. 48. Okay. And then we can print out a message to standard error, which also goes here. But the important thing is that there's no new line added after such a message. And then we can put out a message, something like quirk, and then the thread ID of this thread. Like that. Okay, so now when we run it, and it automatically puts in to the session the expression that we need in order to stop the thread. And since we have the focus there with the cursor, that means I can just press enter and it stops. That's convenient. It makes it much easier to work with. Okay, let's enhance this a little bit. The first thing is it's really boring to just watch the snow coming straight down and not very realistic either. So what we can do is we can make the snowflakes kind of wave back and forth and a little bit. So if we generate a number from 1 to 3, that gives a 1, 2, 3. If we subtract 2 from that, that gives a negative 1, 1, or 0. We can use that to rotate. Oops. Here, so that rotates the flakes, but we don't want to rotate them all by the same amount. We want to rotate each row separately. So we want as many random numbers here in this as there are rows. Let's try running this again. So now you can see they kind of move back and forth like this, so as if each height over the ground has its own layer of air that moves right and left. But we also want there to be a general wind tendency. So if we change this value 3 to say 7, and then we clamp this to be no more than 1. So this generates random numbers from -1 up to 5, because we're subtracting the 2 over here, and clamp to 1. That means that there's a much larger chance of being a 1 than being a 0 or a -1. A 5 times as large chance, because there's 7 possibilities, 2 of which are the -1 and 0, and then the rest of them are 1s. So this will give us a general tendency to rotate towards the left. We should be able to see that the snowflakes are generally moving towards the left, but they still have this flickering motion. Okay. Next step would be to have the snow accumulate at the bottom. Makes it a little bit more interesting. So how we do that? Well, we can, if we draw like an underline, then that would represent fallen snow. And there's a trick. It actually stems from very old days of typewriter terminals, where you could, this is a typewriter, you could print anything on top of anything, and it would visually be overlaid. That doesn't work really on modern computers, but it is emulated a little bit in the function called FMT. So if we take the character underscore, and then I don't actually need this, and then we put a Unicode backspace, and then a letter, then it gets combined like this. But quad FMT always returns a matrix. We just want a single character, so take the first from there. And that works not for every character, but it works for the ones that that we are interested in. Even works for the delta. Make a delta underscore. It also works for space. So if we make this a little utility function, like this, and then we should probably put an each on it so it works on the whole row at once. So now we can write uline, and then we can see XO delta and space, and that gives us underscored. Okay, let's put that up next to our other utility function here. Okay, so now we need to decide which characters is it that we want to underscore. And after we have created the flakes here, then let's see, oh, here in the window, then we want to underline, and we want to underline only at the last row. That's where the snow accumulates. And we don't want to underline everything. We only want to underline the characters that have, or the columns that have had snow. So let's go and initialize head, and that will be the number of columns. So none of them have had in the beginning. And then at the end here, we update the vector that contains which columns have had. So we take the current value or some mask, and we know they have had snow if it's not a space in the last row of the flakes. So if the flake is a non-space, then on the last row, then that column has had snow. But we also want to make sure not to try to underline the trees, because that's not going to work very well. So we also want tree to be different from the last row of the backdrop, the sky. Okay, let's see how that looks. Oh, look, it's accumulating very nicely, and we can see even when a snowflake is hitting the ground where there previously fell snow, it also gets underlined. So it looks very nice and natural. Eventually, the ground is going to fill up with snow, like has happened here, and then it gets a little bit boring. So maybe we should have it start over with a new sky and landscape when that happens. So if we change this end repeat to say we only want to repeat until there are no empty spaces in the last row of the window. So that means every column in the last row is filled either with trees or fallen snow, whether it's a flake or something that's already there. So then we break out of that, and then we can go up and repeat here, draw a new sky. Like that. Let's try it. Thought we just have to wait for the ground to fill up with snow. Shouldn't take too long. Not at this rate of snowing. Just a couple of more left there. And here comes the last one. Yeah, nice. Okay. Now, this has a kind of retro look with these green letters on a dark background. But there's actually a trick we can use that I just figured out recently, and to give this some color. And that's by using, I don't know even if it's a feature, it's not really a bug, but this is really an interesting thing. So let's say that we have a variable foo. Let's say it's a matrix. That's what we're showing. So, and it has some various characters. $sign is not a valid APL character. So now we edit foo, and it looks like this, right? That's the boring retro look that we get. If foo was a function, so let's erase. Here we expunge foo, and then we edit it again. Then we get syntax coloring. And so here's the cool thing. Let's close this again. So, and open it again. I'm opening foo as a function because that's the default when the editor opens up something. But it hasn't actually been defined yet. And if I just close the editor immediately, then there's no trace of foo remaining. But the syntax coloring is has been set. We can actually choose a couple of different things. The syntax coloring has been set to APL, whereas the array would show the nothing. Now, since foo hasn't been defined yet, that means I can go in and define foo as a variable. And that updates the content of the editor, and it updates down here in the corner. It says it's a character array now. But we preserve the syntax coloring because that's already been set to APL. So we can exploit this. Because remember I said that I had a good reason to choose these characters? These star characters, they're all not valid APL symbols. They're just Unicode characters, invalid tokens. The tree is an APL function. These are valid identifier characters. And these parentheses, they are technically part of the APL language, but since we only ever have one moon character, that means either an open paren or a closed paren, that's an easy to spot syntax error. So we kind of have four syntactic classes. Local, global names, depending on where in the syntax they appear. Invalid tokens, APL primitives, and errors. So here's the trick. If we go in and under the colors, so I've been using the Dracula color scheme here, but let's make a new one, which we'll call winter. And then we need to set these four different tokens. So the first one are the identifiers. You can see that the local name is already white. That's fine for snow. Global name should also be white. Then we've got invalid tokens. They're not in the picture here. And they're already yellowish, but let's make it a little bit stronger yellow. Then we have got the APL primitives. And that's just the trees. So let's give them a nice tree color. And then we have the errors, syntax errors here, and then make that a dark gray moon color there. Oh, and then there's the background. We want the single background for everything. Yes, I know. And let's choose a really dark sky blue, like a nighttime sky blue. And then not to make things too crazy looking here, let's also change the session to match the winter theme and use the same background color over here. Okay. Right, so now we've got our updated theme. And now the important thing is, oh, look, I missed one over here. Colors, session, background here. Oh, did I not? Oh, I see. I chose winter. I thought I said change this background color here as well. There you go. Okay, now it looks more sane. Now there's one more thing is that we initialized window here as a variable, but we don't want to do that. We wanted to open it raw before it even exists, so that the editor enables the syntax coloring for APL. That's really the only change that we need to do. So now we can do run. And look, we've got white snowflakes, yellow stars, green trees, and there's a gray moon right there. Snow is accumulating nicely. Just one more left. There we go. New scape. The moon is now up here. Very nice. Let's polish up the code and a little bit. Firstly, I like to put all my my local variables on a separate line over here. Maybe we should add some spacing to group things a little bit. Probably want some comments for the unknown reader as to why we're doing strange things like this. So and then go back to session. And what else can we do? We should probably comment on what these do. So this one is alpha spread out, random alpha cars, and this one is on combine cars with underline. Here we set the variables. Add some spacing over there, and then maybe we should explain as well what's going on over here. But before we do that, I think we can make this look a little bit better as well, because I really don't like using the same variable name twice here to update it like this. I like doing a modified assignment. So how can we do that? So we have a function here, and then we can take this value as right argument, and then that means this function takes on the left argument the original value, and then gets this as right argument. So we can use that to rotate it. Now we've swapped the arguments over here. Then we do a -1 drop on that, and then we put this in front. So it's a little tighter. I think it's a little bit neater. Maybe you call me extreme here. But other than that, this looks pretty good. 28 lines or so. Let's see if it still runs. We haven't made any mistakes. Yeah, and the wind looks nice as well. Okay, so here's the cool thing about using the function called run, and that is let's open the folder that this lives in, and now we can close down our APL, like this, and then right from here we can do run with Dyalog, and that just starts it up right away. So it does that linking thing, creating the link between hash and the folder it came from, and then it runs the program. So thank you for watching, and happy holidays.